We did our project on ramjets and scramjets. The engine mechanics of a ramjet utilize the forward motion of the aircraft to take air into a compression chamber, and the air goes into an intake passage, and the passage has been specifically shaped for optimal combustion. The combustion self-sustains the forward motion after fuel is initially injected and ignited. Ramjets utilize liquid hydrogen fuel to sustain their combustion reactions, and supersonic air slows down to subsonic speeds during this process.
Alright, scramjets are smaller engines because the oxygen they require to combust is taken from the atmosphere around them rather than being carried in the tank of the engine. The engine only needs to hold the hydrogen in its tank, making it smaller. And the scramjet is unlike other engines because, like in a normal jet engine, the fan blades would compress the air, but the scramjet allows the air to flow through at supersonic speeds, compressing the air.
Okay, here we have a short video clip to visualize or provide a visual for how the air goes into a ramjet.
1950s and 1960s were essentially made up of three parts. The central core contained the control instruments. The function of the pointed tip was to provoke shock recompression. The rear end held the injection and combustion systems. The external shell of the distributor, attached by arms to the central core. The ramjet motor can only really function at speeds over 500 kilometers an hour, so air rushes into the air inlet at very high pressure. There it meets with the fuel, kerosene, that is being sprayed in by the injectors. The combustion produced creates a large quantity of hot gas, which is then expelled from the rear of the motor.
Okay, that is all for that video clip. Here we have some engine diagrams, and for the ramjet, you can see that the air goes in and is compressed in this chamber, and then goes into the combustion chamber where the combustion reaction occurs, and then out the back with all of for the shockwave, the pointed.
Very similarly to the ramjet, the scramjet, you can see where the air enters with these blue arrows and where it exits, these red arrows, and then this sort of empty white space with these black arrows in it is the chamber in which the air flows through and combusts.
Okay, here is a diagram that we found, and it shows the relationship between the temperature and the entropy, and the ideal versus actual, and you can see how the increase of temperature also has an effect on the entropy inside the engine. Okay, and so for basic aircraft information, the altitude range is around 12,000 to 35,000 meters for a ramjet, and it has reached speeds of Mach 5 and 6, which is roughly 4,600 miles per hour. It utilizes liquid hydrogen fuel, and it's beneficial because the propulsion system is more efficient for atmospheric flight than rockets.
Alright, scramjet's altitude range is approximately 100,000 feet. The speed reached is between Mach 12 and, which is, I believe, 8,400 miles per hour, but I accidentally added an extra zero. So, and Mach 24, which is 16,000 miles per hour. So the fuel type is hydrogen, and the benefit of scramjets, it allows for simpler, more affordable, and reusable vehicles for future space, military, and commercial use.
Okay, for a brief history, ramjets were theorized in 1928, and the first engine was designed and tested in 1933. And then the Navy implemented the usage of ramjet propulsion in air missiles around 1950. And they did this because the efficiency and speed made it beneficial for new military technology.
Scramjets can be traced back to World War II. So the proposal for faster aircraft was appealing mainly to the Germans during the war and to US and UK scientists post-war. A large amount of time was spent by many attempting to create high-speed planes with no success. And finally, on August 16th, in 2002, the first successful scramjet vehicle flew, reaching speeds of Mach 7, which is about 5,370 miles per hour.